Hello class, for today's lesson is about converting rational exponents and radicals. And here is the learning target. I can convert expressions with rational exponents into their equivalent radical form and vice versa. Just a recap here, a here is our base. So this is the number or variable being raised to an exponent. And here, our m over n indicates the exponent, or specifically, it's a rational exponent or in a fraction form. So, now in this given here, so we read this as the nth root of a raised to m, in which n here is what we call index, or the nth root. Now, here we have the a raised to m, so the inside of the symbol, so a raised to m is called the radicand. And of course, here, this symbol is called a radical sign. Now, again, the index or the nth root is a small number indicating the type root. So it could be a square root, a cube root, a fourth root, or any number or any value of n being given. And the radicand is the number or expression inside the radical. And here again, in the blue, is the radical sign. Now, we have the essential conversion formulas, and starting with the rational to radical. Now, we have here a raised to m over n. Again, a is our base, m over n is our exponent. So if we are to convert this into radical, so we have here the nth root of a raised to m. So basically, your numerator here, your numerator is the one that you're going to raise for the radicand. So here, the numerator. And the denominator is your index or nth root. So that's just your basis. As you can see here, we also have another equivalent form of the radical. So we have here the quantity of the nth root of a raised to m. So either of the two that you're going to use, they're just okay when you're having the rational to radical. And for radical to rational, okay, so again, we just need to identify the n and m on what their roles are. Again, for n, this would be our index is the denominator of a fractioned exponent, and m is the numerator. So basically, we just write the base, just like here, and just remember that the roles of each number. Okay, here, numerator, and this one is the denominator. Easy as that. Now let's have some actual example of converting rational to radical. So here's for example, x raised to 1 over 2. Again, our 1 here, our numerator, is the one that we're going to use to raise the base, or the other form, like this one, where am I? Like this one here, the nth root or the index and the base all together. And also our 2 here should be our index or nth root. So writing this would be 2, then the radical symbol, x raised to 1. However, as you have observed, we haven't actually really have seen anything involving 2 being visible as a square root. Because this one here should actually be, what do you call this? Invisible. Now, why is it so? Have you ever thought of a denominator that is less than 2, which is 1? So if we were to write x raised to, let's just say, let's just use 1 based on this given. Okay, so if our numerator is 1 as a given, and if our denominator is 1, obviously it's just 1 divided by 1, so our x here is just x raised to 1, or just simply x. Then we cannot do the radical symbol here anymore. It's because this value or result is already simplified. And I hope that's clear. Or another example, if we have our denominator or index as 1 again, so if you have 2 x raised to 2 over 1, so obviously 2 divided by 1 is 2, so x raised to 2 or x squared is actually the simplest form of this. That's why we cannot use a denominator which is 1 when it comes to rational to radical or vice versa. So that's why from the word square, which is actually involving 2, so it is noted already that a square root, it has an invisible 2 here based on a 1/2 exponent basis. And I hope that's clear. Okay, let me just erase. And going back, since you already know that a square root symbol should be invisible, so let's also deal with this one, this part. Again, x raised to 1 is just x. So to simply write this in its final form, we just write the square root of x. And that's it. Next example, we have here ab raised to 3 over 4. Now, as you can look closely, only the b has an exponent. So basically, we only need to rewrite b into a radical symbol, with radical symbols. So we write here as a, and again, a should not be affected because the exponent of a is just an invisible 1. So that's it, you just write a. And then the nth root of b, again, our index or denominator is 4. So we write it as the 4th root of, and then b raised to the numerator, which is 3. And this is our answer. Again, only convert or change those numbers or variables that are affected by a, what do you call this? A fraction with an exponent that is in fraction or in rational form. Next, we have this. So 64 raised to 2 over 3. Again, our goal for today is just simply rewriting. But okay, let's just rewrite this first. So again, our 2 is our numerator, which is the one that we're going to use for raising the value. And then 3 is our index, our nth root. So we have this, the cube root of 64 squared. Yeah. However, if this is just our answer in just, writing this. However, if you want to solve this more, find a number in which you could raise 64 to its extent. So it could be 4 raised to 3, because 4 raised to 3 or 4 cubed is 64. Or you could also use 2 raised to 6, because 2 raised to 6 is also 64. Either way, we need to use the simplest form. So instead of using 4 raised to 4 cubed, we're going to use 2 raised to 6. Now, how is it so? If we're going to talk about this, remember that 4 can also be 2 squared, right? And then copying the cubed here, so we get to have 2 squared cubed. So again, in the laws of exponent here, 2 times an exponent having an exponent is to be multiplied. So 2 times 3 is 6. So it just goes back to 2 raised to 6. And I hope that's clear. Anyway, let me erase these first. So as we use this one, we have cube root of 2 raised to 6. We could change this into 2 and then 6 over 3. Again, 6 is our m, the numerator, and our 3 is our index, our nth root, which is the denominator. So 6 divided by 3 is 2. So 2 raised to 6 divided by 3 is 2. So 2 squared is just 4. So this is how we simplify. But again, our goal for today is just rewriting. So I would only accept this one for now. Another example. Wait, let me just add something. If you are given like this, just simple, x raised to negative 3/2. Again, going back to the laws of exponent, based on this, since the x has a negative exponent, so turn this first into changes or transpose this. So this would be 1 over x raised to, again, our negative 3 over 2 would become positive. And then this is the time in which you could convert this part into radical. So this would become 1 over the square root of x raised to 3. So yeah, this is our final answer. Now let's have radical to rational. Okay, so if we have here, so the square root of b. So as you can see here, the exponent of b is invisible 1. And again, this is a square root, and square root is linked to an invisible 2. So we could just write this as b raised to 1/2. And that's it. Another thing, if you were to have 3 cube root, let's just use 4. 4th root of what? A, B, yeah, alright. 4th root of A, B squared, yeah. So as you can see here, our 3 is not affected with anything except for an invisible 1 exponent, so write it as 3. And as you can see here, both A and B has an index of 4. So if we are to write this separately, we have A, and then the denominator would be 4, and then B, the denominator would be 4 as well. Now A here, as you can see, has an invisible 1, obviously, exponent, so we just write it here, 1. And for B, obviously, we could see that it has a 2. B is raised to 2, so create this as 2. So anyway, as you can see here, this is not simplified yet, so that means the final form of this radical to rational would be 3a raised to 1/4 b, and then 2 over 4 is 1/2. And yeah, that's it. let's have next example. Let's involve constant. So let's write this 6th root of 49 raised to 5. Again, this one's just easy because we just need to identify the base first. So 49, and then 49 raised to something. So we have here 5 is our numerator, and then 6 as our index is the denominator. And that's it. Now, what if we're given something like this? 4. 2 over cube root of x raised to 4. Okay, something like this. Okay, anyway, so we don't have any problem with 2 because 2 is already in the numerator, so we could just write it 2. And then our base in the denominator, as you can see, it has been transposed there. So if you are to transpose it back to its original form, we write x here. And then of course, we have here 4 over 3, because again, 4 is a number that we raised for x, and 3 here is our index, or nth root. So yeah, that's it. However, since it has been transposed to the denominator, then that means our 4 over 3 here is negative. And that's it for today. I hope you learned something.